Okay, so actually I got disconnected now. So let us continue. We have to draw first free body diagram for joint A. So all of you will join the free body diagram for joint A. So here what we have initially, I told you that whatever member forces we have, initially we will assume those forces are tensile in nature. Those are tensile in nature. Now you can say that how this 18.92 angle comes. So it is very simple. You can just use tan of theta in this triangle ADE. Then you will be getting what is basically this angle theta, because this height DE is given to you, that is 2.4, and this base of this triangle is 3.8 plus 3.2. It means it is 7 meter. So you'll be getting this angle as 18.92. Okay, you can show the calculations or directly you can show this angle, right? Now, after getting this, we have to calculate now what is FAB and FAC. So for that, we can use conditions of equilibrium, as we have here concurrent force system. So for concurrent force system, we will have two equations of equilibrium. So the first equation is summation f of x equals to 0. So here we have this equation FAC plus FAB cos of 18.92, that is equal to 0. So FAC plus cos 18.92 is 0.95 into FAB is equal to 0, and let us say this is equation number 1. Now similarly, use equation of summation f of y is equal to 0, and you tell me what is the value of FAB. Okay, I'll wait for your answer. What is FAB? Use the second equation of equilibrium, that is summation f of y is equal to 0, and get okay. Mitali shared some answer here. Any other answer? Ayush shared some answer. Kajal also shared some answer. Sahil, Shivam, okay. Abhijit, Sharvil, okay. So I found that all of you are having a same answer. Okay, so let us see the next step, means the calculation of FAB. So when we'll take f of y is equal to 0 in this case, then we will have this equation that FAB is equal to, means 21 minus 5.7 plus FAB sine of 18.92 is equal to 0. But when you will calculate this FAB, you are getting the answer as minus 47.19 kilonewton. You maybe are getting 47.18, no issue. There may be some differences of some decimals, so no issue. So the answer is minus 47.18 or 19, as you are getting here minus sign. So minus sign indicates that, or as we already discussed, this minus sign indicates that assumption for FAB is wrong. Hence we need to correct the assumption, means FAB is compressive in nature. You can see here FAB is compressive in nature. So here we are getting the value of FAB as 47.19 kilonewton and show it as compressive in the bracket. Okay, now when we get this FAB as minus 47.19 kilonewton, and when we put this value in equation number 1, we have to put here value of FAB as minus. Okay, why we should put here minus sign? The reason is that when we derive this equation summation f of x is equal to 0, earlier FAB was tensile. Okay, so that is one and the same. Either you correct this equation or you just put here minus sign. That's it. Okay, so we'll put here just simply FAB as minus 47.19 kilonewton. Okay, just a minute. Okay, so here we are getting the answer as 47.1. Sorry, when we put value of FAB as a minus 47.19, then your equation 1 becomes, means you will be getting the value of FAC. Now here you will be getting value of FAC as plus 44.83 kilonewton. So you are getting here plus sign. Plus sign indicates that assumption for FAC is correct. So hence you are getting FAC as 44.83 kilonewton. Okay, which is tensile in nature. Which is tensile in nature. Okay. Any difficulty in this now? Calculation of FAC and FAB. That is very important. Now, after Correct. 44.83 away from the joint. See, after getting these two values, FAB and FAC, we have to show it in this diagram. Okay, so initially you have drawn this diagram in means the FBD. So you have to show this. Let me show you how to show this. Just a minute. You can see now. I have shown it in this next diagram. You can show it. Just ignore about this joint B. First you see FAB I have shown and FAC I have shown. FAB was compressive in nature and FAC was tensile in nature. Okay. So therefore FAB as compressive in nature and whose value initially we found that it was 47.81. So all of you will write down here this value as 47.81. Sorry, 1818. And the value of FAC as 44.83. Okay, so all of you will show these two values and their nature. Tensile means what? Away from the joint, and compressive means what? Towards the joint. Okay. So now we'll be focusing on this next joint, that is joint B. Now, at the joint B, if you see what we have this force of FBD. FBD. So I have shown it, FBD. That is tensile in nature, right? And I have shown this FAB force, which is compressive in nature, means which is towards the joint, and that is 47.19. Fine. Okay. And here at a point B, we have this next force, that is FBC. Again, I assume it as a tensile in nature. Okay. So now if you see this particular free body diagram, again, how many unknowns we have? Only two unknowns, that is FBC and FBD. So you can again solve this particular equilibrium, and then you will get the value of FBC and FBD. So once again, you will see the first equation of equilibrium. Okay. So here we have the first equation of equilibrium, that is summation f of x is equal to 0. Is equal to 0. Okay. So when we take summation f of x equals to 0, in this case, we will have FBD cos of 18.92 plus 47.19 cos of 18.92, that is equal to 0. Okay, when we put f of x equals to 0. So here we get value of FBD as again minus 47.19 kilonewton. So again, this minus sign indicates that the assumption for FBD is wrong. So we need to correct this assumption that FBD as 47.19 kilonewton. Now, can you just calculate what is FBC? And you will be telling me what is the value of FBC. Okay, some of you are solving. Utkarsha shared some answer here. FBC. The remaining students do summation f of y is equal to 0. Do this calculation, summation f of y is equal to 0, and get what is FBD equals to. And you're also telling me what is the nature, whether it is tensile or compressive. Okay, so here we have this next calculation. So when we put summation f of y is equal to 0, now in summation f of y, we have first minus 10.5, then minus FBC plus 47.19 sine of 18.92 plus FBD as 18.92. See now, again there are two ways. Either in this equation, you derive the equation just by observing the diagram, and then you put value of FBD as minus here, no issue. Or you just correct the direction of FBD, means it is compressive, means its component will be minus here. So that is one and the same. Either you correct the equation or you correct the value of FBD. That is one and the same. So if you use this original diagram, which we have drawn earlier, and then if you are deriving this equation of summation f of y, then you just put value of FBD as minus 47.19 in this equation. Okay. So when we'll put here FBD as minus 47.19, then you will be getting value of FBC. See now, most of you have made mistake right now that all of you are saying it is 10.5 kilonewton tensile. That is wrong. When you will be calculating FBC here, you will be getting here minus 10.5, considering value of FBD as here minus 47.19. Don't say here minus of minus FBD. Okay. Either you correct the equation or you correct the value of FBD. Okay. So some of you are made mistake here while calculation. I know the mistake. It is because of this value of FBD. Okay. So either you put here minus 47.19 or you write down the equation as it is, that is minus FBD. But here we are observing this original diagram, that is free body diagram, means we will be using the same diagram and we'll be putting here plus FBD according to our assumption. But afterwards we found that it is minus 47.19, means we put here minus sign. Okay. So here you are getting FBC as minus 10.5 kilonewton. It means that it is compressive in nature. It is compressive in nature. So you will be showing these values. You will be showing this value, that is FBD as 47.19 and FBC as 10.5 kilonewton compressive. Okay. So here we'll show it here once again. So as I shown here, FBD as 47.19, okay, and FBC as compressive, and that is equal to 10.5. You can show in the diagram, your diagram, 10.5. So now can we go to joint C now? Yes, we can go, because at joint C total 4 members we have, but out of that now 2 are solved. So 2 are known to us. So the remaining forces are CD and CE. Some of you have shared here wrong answer 20.102. That is wrong. Ayush, Ajinkya, Damini. You just check your calculation and do it once again. So now we can draw the free body diagram for joint C now. So at joint C, what we have? At a joint C, we have the first force, that is FCE. So again, as per our assumption, we have shown it initially as a tensile. Next force, we have this inclined force, that is FCD. Now this angle we have to find, that is 36.86. How we can calculate it? Again, in this triangle CED, this CED triangle, we can take tan of theta. Here tan of theta, suppose this is theta. So you can take tan theta, and then you take tan theta equals to DE upon C. D is 2.4 and C is as 3.2. So you'll be getting this angle as 36.86. Okay, that is 36.86. So now here we have this 36.86 angle. Now again we have two unknowns. So the force in FCA we have shown already, we have already calculated, that is 44.83, and that is tensile in nature, no problem. And the force in member BCS compressive, and that is equal to 10.5 kilonewton. Okay, right. Now again we have two unknowns, so we can use conditions of equilibrium and we'll get this value of FCD and FC. So now I will give you some time. You have to calculate your own. So it will help you to practice on this method of joint. So solve this particular joint and get what is FC and FCD. Okay. So I'll give you some time. All of you will solve this and I will ask question randomly to anyone. You should be able to give the answer here. Okay.
Yes.
Okay, so now let us see the solution for FCD and FCE. Okay, some of you have shared your answer, and I found that it is almost they are matching 17.51 and 30.6 or 7. Okay, so here we have this answer. So when we take summation f of x equals to 0, we get one equation in terms of FCE and FCD. And when we calculate the next equation, that is summation f of y is equal to 0, then we are able to get this FCB and FCD. So FCD, we are getting it as 17.5 kilonewton, and that is tensile in nature. That is tensile in nature. Okay. Now similarly, we'll get value of FCE here. So for that, we have to put value of FCD in equation number 1. So when here now, when we put value of FCD, you have to take as it is, that is 17.5, because assumption for FCD is correct here. Okay. So when we put FCD equals to 17.5 here, then we get value of FCE. So here we get value of FCE as 58.83, and the answer is not matching. Why? Is there any mistake in my calculation or yours calculation? Ayush is getting the same answer. Okay, you are getting FCD as negative. How it is negative? Is it negative, FCD?
Sir,
What is the
FCD,
mistake here?
sir,
Huh?
FCD चा component plus FCE चा FCE is equal to 44.83 पाहिजे ना.
एक मिनिट चेक करू आपण. FCE plus FCD cost of 36.86 and minus 44.83. काय रॉंग आहे याच्यामध्ये? घेतला ना कॉस्ट कंपोनंट?
त्या दोघांची ऍडिशन एवढी यायला पाहिजे ना.
सर
इथे दोघांची
FCE
ऍडिशन
30.8
एक्सपेक्ट करताय ना.
येतोय.
एक मिनिट, आता हे इक्वेशन नंबर 1 करेक्ट आहे का?
हो,
ते करेक्ट आहे सर.
पण
जर
FCD ची व्हॅल्यू
Okay.
त्याच्यामध्ये
हा, ते correct
टाकल्यानंतर FCE चा
17.5 व्हॅल्यू टाकली तर ते मग
Okay.
0.8 इंटू 17.5 14 होईल आणि मग ते 30.83 येते.
1 minute. आपण आता सेकंड इक्वेशन चेक करू. So in second equation, when we take summation f of y equals to 0, minus 10.5, is it correct? Next, FCD sine of 36.86, इथपर्यंत इक्वेशन बरोबर आहे का?
हो.
हो.
Okay. आता when we'll take FCD is plus 17.5, हे करेक्ट आहे कॅन्सर?
हो, ते बरोबर आहे.
हो, करेक्ट आहे.
ओके.
हा.
हा, आता दॅट इज प्लस or मायनस FCD?
प्लस बरोबर आहे ते.
प्लस बरोबर. So we'll put here FCD as it is.
हा, मग त्याच्यानंतर त्याचा आन्सर 30.83 येते.
एकदम मायनस होईल ना सर 44 मधनं.
ओके. हा. So 0.8
कमी यायला पाहिजे FCE.
correct. So the answer is wrong here. So what is the answer here?
30.83.
Okay, so you just make the changes. That is wrong answer. It is 30.6. Correct?
83.
83. Okay. So you just correct this now. FC is at 30.83. Right? And it is tensile in nature once again. Okay. So in the diagram as well, you have to show these forces FCE and FCD. Okay. So now we have completed now joint C. So now finally we'll go to joint E now. Okay. Joint E. We have to show all these forces. Now there will be some mistake here. As FCE, it is not 58.3. So you just correct it now. It is 30.83. 30.8. Okay. 30.83. So here also you need to correct the direction. Need to correct the direction. So all of you correct the direction. So accordingly now, for last join E now, we have 3 members once again, and out of that one is known to us, that is 30.83. So now here the calculations are very simple. When you will take summation f of x equal to 0, it is minus 30.83 minus 30.83 plus FEG. Okay, so when we put here 30.83, here you will be getting the answer as, so your answer will be, so your answer is 30.83. Okay, and that is tensile in nature. Okay, and what about FED here? Sorry, FED. When you will take summation f of y is equal to 0, nothing is there other than FED. So FED is equal to 0 in this case. Fine, it is 0 in this case. Okay, it is 0 in this case. Now, yes, it's 0 in this. So when you show a 0 member force, you have to show like this always. Don't show any direction because it is null or 0. So you just mark it as a 0. Okay. No, Ayush, how you are 9.6 here? No, when you think about joint E here, when you think joint E, nothing is there other than these 2 horizontal forces. Sharvil is saying, sir, so can we say at a point E, one force has negligible load? Yes, negligible means it is 0. It's not negligible, it is already 0. Now, based on this concept of 0 value, we have one more additional concept that is called as concept of zero force member. Okay. Now, what is basically a zero force member in MCQ also? In MCQs, maybe some diagram will be given to you and you have to identify which member is a zero force member. Okay. Now, to identify the zero force member, we have some logic. Now, here we have calculated value of FAD by drawing this free body diagram, and then by taking summation f of y is equal to 0, we have calculated basically that is zero force member. Okay. So someone may ask that if it is 0, can we remove this member? Okay. If it is not taking any load, yes, Sahil is asking, sir, there is no role of center rod, so can we remove it? Yes, that is a good question. It was expected actually. So Sahil asked this question. Yes, we can remove it. If it is a 0 value, then why we should increase the cost of the structure? Why we should add here this member? I will tell you the reason afterwards, after discussing the concept of zero force members. Okay, after discussing this concept of zero force member. But before that, let us finish this now example. Now you can say that how you are going to finish this example, sir. Now you just observe this given truss. You just observe this given truss. First thing, you observe the all support conditions. See, here value of Rx is 0. So do not consider this Rx here. Okay. You just think about this RAY and RB. Both are same. Both are 21. Correct. Both are 21 here. Means support conditions are symmetric here. Right. Now, you just observe now the second part, that is the forces acting on a structure. Here if you see at a point D, exactly at the center the load is 9.6 kilonewton, and exactly at similar distances, means at a point B and at F there are 2 loads, that is 10.5, 10.5. Again means this load is symmetric. Similarly, again at A and at H the same force we have once again, that is 5.7, 5.7, right? Now if you see all these distances from point E now, distance EG and distance CE, again it is same. Again distance GH and distance AC, is same, means this truss is symmetric in terms of the external loading acting on the structure, in terms of the support conditions, and in terms of all geometric conditions. This truss is symmetric. Okay, so when we have such symmetric truss, it is not necessary to calculate the remaining part or the symmetric part of the truss. Okay, if you are solving it, no problem, you will be getting the same answer, so you are wasting your time. Okay, that is not necessary at all. Means if you start from joint H, all same conditions we have. Here we have 21 force, 21 kilonewton force. Here we have 5.7 kilonewton force. So same thing, when you will calculate FFH and FGH, you will be getting the same value of FAB and FAC respectively. Okay, so it means that when this truss is symmetric in terms of the support conditions, in terms of the loading conditions, and in terms of the geometric conditions, we can say that the given truss is symmetric. Hence, it is not necessary to calculate the remaining member forces. So exactly 50% part of the truss we have solved. So remaining 50% part will be same as it is. It will be same. Okay. So it is not necessary to calculate once again. Okay. So I hope you have understood this example now. Now we have to see the rules to identify zero force members. Okay. We'll solve one problem here on the rules of zero force member. All of you should write down here rules to identify. There are only 3 rules. One by one we'll see. Zero force members. And also I will give you the reason why we cannot remove that member. Okay, so all of you write down here rules to identify zero force members. Okay. Give the title in your notebook, rules to identify zero force members. That is very, very important part. If you want some smart work in the given truss, then these rules are very, very important. These are very helpful to directly solve the example. Okay. So now in that, our first rule is that, okay, today we'll be discussing only rules, and based on this, the example will be solved in the next lecture. Okay. So the first case is that, now here is the first rule. So I'll show you the first rule. When we have 2 members connected at a joint like this. Okay, when we have 2 members connected at a joint. Okay, maybe such condition we have. Okay, and I can add one more condition, that if I have a roller support at this joint, for example. So just understand it carefully. It is very, very important. This is our first rule. Okay. By this diagram, you will understand now. Okay. Now the first rule is that if there are 2 members connected at a joint, you can see now here in the first case, 2 members are connected at a joint, and out of which one external force is acting along one of the member. For example, here the external force is acting along one of the member. Okay, what I am saying, if 2 members are connected at a joint, and out of that, if the external force, any force, for example, this is a force F, is acting along the one of the member, means its axis of the member, then the second member becomes a zero force member. It becomes a zero force member. Okay, I hope you have understood this rule. Once again I repeat it. When 2 members are connected at a joint, out of which one external force is acting along one of the member, then the second member becomes a zero force member. Okay, I hope you have understood. Again, I will explain it for this diagram as well. In this case, again, 2 members are connected, and suppose external force is acting along one of this member. Suppose this is one external force. So in this case also, this second member becomes a zero force member. But condition is that there must be 2 forces. There must be 2 forces, right? In this case as well, for example, external force is acting one of the member, acting along one of the member. In this case also, this second member becomes a zero force member. It becomes a zero force member. Now, in this case, what happens? There is no any external force, but when we have a roller support, you know that there will be a reaction, right? There will be a one reaction. And what is that reaction? You know that when we calculate it, it is exactly normal to the surface. So in this case also, so this is the reaction. So here also, though it is a reaction, but it is acting along one of the members. So what about the second one? It becomes a zero force member. I hope you have understood this rule. This is the first rule. Okay. Again, I repeat the sentence. If two members are connected at a joint, out of which the external force is acting along one of the member, then the second member becomes a zero force member. Okay. Now we'll go to the second rule. Okay. You can draw this diagram simultaneously with me. Now we'll have a second rule. Now what is the second rule? I'll again show you second rule. If three members are connected at a joint, suppose here we have a joint where three members are connected like this. Okay. Three members are connected. Okay. And in this case, suppose these two members are collinear. These two members are collinear. In given diagram, you can see now there are three members connected at a joint, and out of these two are collinear, right? I'll show it like this. So these are two collinear members. Okay, means their axes are same, and no any external force is acting at this joint. If there is no any external force acting at the joint, then this third member becomes a zero force member. If you observe our last example, the same case we had, you can see the diagram, you can understand. Okay. In this case also you can see two members are collinear. Out of these three members, means when three members are connected at a joint, out of this two are collinear. These two are collinear. Then, and if there is no any external force, that is very important. If there is an external force, then you cannot say it is zero force member. But here there is no any external force here. Then you can say that this is a zero force member. This is a zero force member. Okay. So exactly if you see the last diagram, means the example which we had solved, this vertical member was zero. Okay. After solving that, we obtained that it is zero. But you can identify it directly just by applying this rule. Okay. So this was the second rule. Once again, I repeat it. If three members are connected at a joint, out of which two are collinear, and there is no any external force acting at the joint, then this third member becomes a zero force member. It becomes a zero force member. Okay. Now we'll go to the last. It is very simple rule now. That is number 3. That is very simple. Now the number 3 is that if two members are connected at a joint, and out of which, like this now, if two members are connected at a joint and there is no any external force at this joint, in this case, both members becomes zero force members. Okay. Means two members are connected here, but there is no any support condition. There is no any load. It means that both are zero in this case. Both are zero. Such case may be observed in case of a cantilever trusses. Okay. I'll show you some examples afterwards. Okay. So this was the third rule. Again, I repeat it. What is the third rule? When two members are connected at a joint and there is no any external force acting at the joint, then both members becomes zero force members. I hope you have understood all these 3 rules. Any difficulty, any doubt in these 3 rules? Once you understand that, just by observation, you can identify what are the zero force members in a given truss. Okay. And what is the significance of zero force member? Why we cannot remove it? That answer I will discuss while discussing the example. Okay, while solving the example on zero force members. Any difficulty in these 3 rules? You just remember these 3 diagrams. It is very simple to understand. You can take a screenshot of these 3 simple diagrams. Okay. Only one student replied here, no doubt. What are the remaining students?
No doubt, sir.
Any problem in this? Okay, very good, very good. So these are very means simple rule, and it is required for any smart work. If you don't want to calculate it, otherwise what happens if you don't know these rules, you have to do this calculation. You have to draw the free body diagram, then get the equation of summation f of x, get equation of summation f of y, and then try to get this unknown things. Okay, but if you know these rules quickly within a second, you can just identify which member is a zero force member. Okay, but though these are zero force member, you cannot remove it. I'll tell you the reason afterwards. Okay, in the next lecture, definitely I'll be telling you. Okay, now I think time is over. I have taken the attendance because afterwards to take down the example again will require 15 to 20 minutes. So better way, we'll stop now. If you have any doubt, you can. If you have any difficulty, you can ask. The examples based on the method of join or the problem of assignment, I'll give you in the next lecture. Okay. So in the next lecture, we will solve one example on zero force members, and then we have to go to the next method that is called as method of section. Okay, that is called as method of section. Okay, so for today now we'll stop, but till if you have any problem, you can ask. Otherwise, you can leave the session. No problem. You can leave the session if you don't have any problem. You can leave it. Okay, so now I'm going to end this today's session. So thanks to all for such a nice response from your side. Thank you all. Srikanth, Vedasri, thank you.